So up until now, we have been only working with the graphs that do not have any cost or weight on its edges. And from now on, we will be dealing with algorithms which handle the graphs which are weighted. So on the left hand side, you can see the usual graph that is familiar to us, and on the right hand side, you can see the weighted graph. So what is the weight? The weight is these numbers on top of the edges or close to edges of the graphs. And sometimes this weight is also called cost or length of the edge, so you can use those terms interchangeably. And so the algorithms that work with weighted graphs are Kruskal's algorithm, Prim's algorithm, Dijkstra. But for the minimum spanning tree, today we will see Kruskal's algorithm. But before going on, let us define what is a spanning tree and what is a minimum spanning tree of a graph. So a spanning tree of a graph is an acyclic subgraph that connects all vertices. And here we should remember that the graph is undirected and weighted. And respectively, the minimum spanning tree is just the spanning tree which has minimum weight or minimum cost. And the weight of the graph is just the sum of all its edges costs. And so this is our graph G, which we will use for illustration in this video. And before going further, I want to tell you that in what kind of edges are not allowed in minimum spanning tree. So basically there shouldn't be any loops, cycles, so to say. If for example, we cannot include this three edges altogether in a spanning tree because they create a cycle inside the graph, inside the tree. So we cannot, just minimum spanning tree just simply cannot have any cycles. And also there shouldn't be any parallel edges and also self loops. So this kind of edges should be eliminated. But the idea of the spanning tree is that it connects all of the nodes in our graph, but do not have any cycles. And the idea of the minimum spanning tree is to get the spanning tree whose cost is the minimal. And now let me write the costs of the edges. So the cost of the edge AB will be 3, AC will be 9, AF will be 5, BE will be 6, and BD, let it be 8, and CE will be 4. So in this weighted undirected graph, in the following minutes we will find the minimum spanning tree using the Kruskal's algorithm. And it's actually pretty simple. The very first step of the algorithm will be to write out all of the edges that we have. So alright, so let's start from from A, just alphabetically, it doesn't really matter. So from A we have an edge to B and its cost is 3. Or alternatively you can write it as A, B, 3. And then we have A to F, and this is 5. We have a graph, an edge from A to C, and it costs 9. And then we start with B. B is equal to 6. BD is equal to 8. and we have one more, which is CE, and its cost is 4. Alright, so if we count all of the edges, we have 1, 2, 3, 4, 5, 6 edges altogether. So this is just an alternative way of writing the graph, so you can write it like this or this, but I think professor prefers this way. And the next step, I just cleared some space just to have more space for the to show the algorithm. And the next step will be to sort these edges in increasing order according to their weights. So actually what we are doing is just a minimum priority queue. So the minimum edge among all of them is AB, whose cost is 3, and then we have CE, which is 4, and so on and so on. So we have sorted out our edges, and then in the next column we will have the initial graph edges as separate trees like this, and then here we will also have one more column. I will tell you later what is that. So we look at the edges nodes A and B, and we see that they are separate trees. Actually they are separated with column here, so that means they are separate two separate trees. So here we will have some sort of safe or not safe column, and here we will write that AB is safe. We will say AB is safe because these two nodes are in two separate trees. So we put a plus sign here and we go further, and in the next iteration we will connect these two nodes, because we kind of merged these two trees together, and we look at the next edge we have, and this is CE, and we look at our tree. So as you can see, C and E are two separate trees, so this is safe, we can merge them together. CE, G and F, and in the next cycle our new tree will be new edge will be AF, and we see that A and F are in two different trees, so we are good, and we say A, B, F, C, E, and D. So now we have 3 trees, and we look at BE, and we see that B is here, E is here, so we are good. We connect these two graphs, C, F and D, and then we come to BD, and we see that B is here, D is here. We can merge these two trees, and we got this whole tree. And then we look at AC, but we see that A is here and C is here, so these two nodes are in one tree, and this is not okay. So we put a minus sign here, and this is the end of the algorithm basically. But I will just to visually show you, our spanning tree is so AB. Everywhere where you have plus sign, you can make a double edges. So here we will make double edge AB, and C is also okay. So we make here double edge AF. So we do this like this, and BE is also okay. So we do this. BD is good, so we did this, and yeah, that's it. So this is the minimum spanning tree of this graph, and of course there might be many minimum spanning trees, but this one is just one of them. And if you count the weights, and then surely it's the minimum cost. So basically this is it about Kruskal's algorithm, and in the next video I will talk about Prim's algorithm.